So now let's talk about a concept called conditional probability. Conditional probability is the probability of a particular event occurring given that another event has occurred. So basically what you're looking at is the joint probability of two things happening divided by the probability of one of those two things happening. And so when you see how it's written, here we have P parentheses B vertical slash A close parentheses. That's actually being read the probability of B given A. So if we wanted to look at the calculation of here would be the probability of A given B, is we have the joint probability of A and B occurring divided by the probability that B occurs at all. So let's look at the example of Collins Mining being profitable given that Markley Oil is profitable. So we calculated when we learned about joint probability that the probability of both Markley Oil and Collins Mining being profitable is 0.36. And when we calculated the probability of Markley Oil, we found that that was 0.70. So when we use the formula on the previous slide, we look at the portion that satisfies both Collins Mining and Markley Oil as being 0.36 out of the probability that Markley Oil is profitable at all is 0.70. We get a value of 0.5143. So what this is saying is if we assume that Markley Oil is profitable, we have a 51.43% chance that Collins Mining will also be profitable. We have the general rule of multiplication where we look at the probability of A times the probability of B given A gives me my joint probability value. And so it's very easily demonstrated by looking at flipping a coin 2 times. So if we look at it from the classical probability perspective, I flip a coin, I can get heads or tails. If I do this with 2 coins, I can get heads or tails with both coins. So I get the different combinations of heads on both coins, tails on both coins, heads on the first coin with tails on the second coin, or tails on the first coin with heads on the second coin. And so the probability that I get the result of getting heads on both of my attempts is 1 out of 4. We can come to the same conclusion by saying I have the probability of having the coin land on heads on the first coin is 0.5, and if it happens on the second coin, that also is going to be 0.5. So the probability of both of these events occurring is going to be 0.5 times 0.5 to give me a 0.25 probability. Let's look at this in the perspective of our Bradley Investments example. So remember, the multiplication rule was using our conditional probability value and what we'll learn later is called the marginal probability value to find our joint probability of both Markley Oil being profitable and Collins Mining being profitable. So when we first started talking about probability, we calculated that Markley Oil was going to have a 0.7 probability of being profitable. And when we started learning about conditional probabilities, we learned that the probability of Collins Mining being profitable, given that Markley Oil is profitable, is 0.5143. So if we then plug this into the calculation of the formula that we saw in the previous slide, we get that the joint probability of Markley Oil and Collins Mining being profitable is 0.36, which is the same value that we calculated earlier when we were looking at the definition of the probability of an event. Oftentimes, specifically when we are looking at conditional probability, we represent our probabilities in a contingency table. So here in the center portion of our diagram, you see the 0.36, the 0.34, the 0.12, and the 0.18. Those are your joint probability values. So those are going to be the values of what happens when an event satisfies both criteria on the chart. The values on the side in the total column and the total row, those are called your marginal probabilities. Those marginal probabilities completely belong to just one variable. So if we're looking at this, the way we would read this is the 0.36 is the joint probability of both Collins Mining being profitable and Markley Oil being profitable. The 0.70 in that total column on the far right only applies to the probability of Markley Oil being profitable. So if we're working with conditional probability, if I were to ask what is the probability of Collins Mining being profitable given that Markley Oil is profitable, I would do the 0.36 divided by the 0.70 to get the value that we calculated earlier. Sometimes when you see contingency tables, they're not always represented in terms of probability. Sometimes they give you the actual number of occurrences that satisfy those criteria. So sometimes it's also helpful if you're saying that I have a 0.36 probability, joint probability, you might want to assume that you're working with 100 events. So you could very easily see 36 for your joint probability of Collins Mining being profitable and Markley Oil being profitable. So contingency tables can be very useful in helping you figure out these different relationships to, to determine what probability you need to be looking at.